and our, we can say that the colleagues, because we are working together and because of the cooperation of the others, we
Yes.
can do something, madam. Yes. I have filed the patent, I have published the patent, and three are about to publish. So total 15 that I have published,
Yes,
but
yes.
out of this 15, three are about to grant also. So I am reaching to that stage. Yeah.
Yes,
Thank
sir.
you, madam. Thank you very much. Let me give some brief information about the topic that is the antennas for IoTs. Let me share the screen so one can see
Yes. Screen is visible, sir.
and okay, fine. Is it okay now?
Yes, sir.
Yeah, yeah. So thank you very much. Uh, Good morning to all, one and all those who are there. Some of the faculties are senior to me, some of the faculties are like me. So we all are in the learning environment, right? So let's learn something on antennas for IoT application, RF and micro aspect of IoT. This is my core area. Uh, I'm also handling one research center, means rather, I'm a professor in charge of Center of Excellence of my institute. It is known as LR. It is Electromagnetics and Antenna Research Center. And this is in my mind that at least if you would be a director or principal or vice chancellor or any other post, at least you must have one laboratories. By this lab, you are knowing the outside world. And happy to share that I have helped the even NIT Nagpur students, SVNIT Surat, even industries, even all the institutes of the Gujarat, all almost 8 to 10 institutes of the Gujarats, I mean MTech and PhD students for their research, testing and all. So that's why I am just looking this lab, which is known as Electromagnetics and Antenna Research Center. So I wish to introduce these things to you also. Yes, my institute, let me give a brief introduction of my institute because my institute it has a legacy. It was started in 1948. It was a dream of our Sardar Vallabhbhai Patel. And obviously, we are having a very good database of alumni that includes eminent industrialists, MDs, CEOs, ministers of the state and Union of India. We have produced 20,000 graduates, and we are the only UGC autonomous institutes in Gujarat. We are the first engineering college of Gujarat, established in 1948 with the status of government heritage institute, managed by my Charutar Vidya Mandal. This is the management, which is the, I mean, Gujarat, we can consider as a institutes or management, which has a most of the, I mean, more than 15 number of institutes are under the umbrella of CVM. So yes, presently our engineer Bikubai Patel, who is also my institute's alumnus, so he is looking the that things. Yes, we are, as I said, we become first autonomous college of the state in 2015, established in 1948. NBA and I mean NBA is awarded. We have applied for the NEC. So again, as an engineering institute, we are first in Gujarat who are going to apply for a NEC accredited. So even though we are not university, but it's autonomous institutes, and we have planned for the NEC also. So this one is, and yes, our admissions are, I mean, we have a meritorious students of the Gujarat up to a rank of 2000s. So that's why I think we can do a better learning to our institutes. Our students can improve also. 100 corporate visit of the college for conducting the campus interviews, yes, and more than 90% eligible students are normally placed in every year. Yes, this is a statistics just because nowadays the mixed modes are going on, right? So we have a granted institutes, we have a self-finance institutes, we have a PG program also. And now recently we got the PhD center by the Gujarat Technological University to whom we are affiliated. This is the vision, just I mean vision and missions for our institutes. We produce globally employable innovative engineers with the core values. Re-engineers, as far as mission is concerned, we have a 5 missions. We develop the faculty and staff, we reform the policy, we imbibe the core values. We promote the innovative practices. We re-engineer the curricula to meet the global employment requirements. This one is our governance systems. I think every institute, those who are, excelling, they are following this one, and we are also following some basic governance systems. We have a strength and practices also. We have a one-to-one student, one-to-one faculty's interaction with the industries. So till now, we have a 250 plus industries are with us, and we have done MOU also. We also signed, this one is the details again on best practices. That is the curriculum revisions are happening, OBE are followed. We are three times NBN accredited, so obviously we are following some good practices and qualities at our campus. Yes, we have signed MOU with the foreign universities also. So our students are going there. So and they do the internship, they do the some training, and then we can. They come back here. We consider some. The minor degree and the major degree also. Then there is a strength and best practices are always there. We have organized total four international conferences. Two are exclusively for women. It is a woman in science and technology. So co-author may be a man also, but one woman is compulsory for every papers. That is because organized by the our woman cell and woman team, those who are very excellent in the organizing. We have also supported the one institutes under the TQ projects. It was given by the World Bank through AICT, and we have organized four events, four international conference with the our tuning partner. It is a GC Banswara. I have worked as a tuning coordinator. That's the glimpse of the MOU signed with the industries. This one is N2PL company's CEO. We have done MOU with them, and we have established the laboratory with the help of these industries. This one is about the MOU signed with the Illinois universities. So one professor was present and we have signed the foreign universities. Okay, this is about my institute's background. I am associate in admin, and so this is my humble responsibility to share the what we are doing to you. Thank you. And now I come to the technical ideas and technical details. So what is my agenda? What is my planning to discuss? First one is let us see some basics. IoT performance response on the other technologies. Yes, your antenna plays a very important role. So selection of antennas for a small IoT devices are very important. The IoT considered as an ecosystem for the antenna developed at our lab, LR. This is a research center actually. Requirement for RF system design and testings, what kind of arrangement is needed and what we have, how we can help to the others also. And then there is a conclusion. So this one is my agenda. Yeah. My first point to be discussed is the what are the impact of the electromagnetics. If you see the electromagnetic is penetrated now in the lot of technologies. If you dream of biomedical engineering and biotech, again you need instruments where electromagnetics are the, it plays a very important role. Same way signal processing and imaging, computer chip design and circuits, because again you need a EMI and EMC kind of concepts for making any chip design. Even laser and optoelectronics, the fundamental base of this of electronics is again electromagnetics. So obviously, electromagnetics fundamentals are needed if you dream of radar engineering, then, or if you dream of any microsystems or a MEMS, I think electromagnetics knowledge is important. Same way, there is a remote sensing and subsurface sensing and NG. Then there is a EMC and EMI analysis. Then there is antenna analysis and design. Then there is a radar cross-section analysis design. Then there is the wireless communication propagations. So we can understand that the electromagnetics are penetrated every field. Of mathematics. Okay, the, some of our other faculties or colleagues, antennas are basically the structure. If you see, it's like the layer structures. So it has a ground terminals, right? Obviously, it is made of metallic material. Then there is a dielectric material, and top of it is known as a patch. Patch is again it is made of conductive material. So there is a conductive material at last at ground plane, and at the top there is another conducting material is there. And between this there is a dielectric materials. So that is nothing but you can use any kind of dielectric. That may be a epsilon r is equal to 4.43 like FR4, or you can go with the PTFE with the values of epsilon r is equal to 10. It depends on the how you analysis, how and what is your requirement, what kind of parameter you need it. Do you want to see the antennas gain high? Do you want to, do you want to increase your bandwidth? You need efficiency high. You need, the flexibilities. So this kind of requirement, the target parameters are very important. And with this target parameters, one can understand that they you have to design or you have to select the material first in such a way. This one is nothing but it is you can say that the feed lines. So because it gives you a signal at this point. So when you give a signal at this point, that will be basically do the do the signal transfer from one point to another. So what the signal you are giving to this that is the electrical signals. Once it is sent to the patch, right? Between patch and ground plane, the field is produced, and that is the fringing fields. So this field is finally it is propagated in a air. So you are going to convert electromagnetic signals from electrical, right? So that is very important. Electrical signal to electromagnetic conversion is provided, or rather transformation is provided by antennas. So that is the main role of antennas. Obviously, you can do reverse operations if you have receiving antennas. If you have receiving antennas, then what happens? Then you have a chance of conversion from electromagnetics to electrical signal. Obviously, it does this. So antenna is basically we can say that it is a transducer which converts electrical signal into electromagnetic waves and vice versa. If I am using a transmitting antenna, then it converts electrical to electromagnetic waves. If it is a receiving antenna, then it converts electromagnetic waves into electric signal. So this is the structures and field is produced with respect to these two sides, right? Because it is in the same directions. And that provides your propagations, that provides your radiations. So what I'm transferring to this point means here we can say that the feed points. And if I'm giving some power, maybe a 2 watt or something. I think it is very large, but maybe let me say 2 milliwatt. And this power, maybe a 1.5 or something can be radiated by. So that is the output by input power is the efficiency. So sometimes what happened, antennas efficiency need a high. Your requirement is high. And on the basis of that, you have to select the epsilon or R. And on the basis of that, you can select the antennas material. Right? Now, patch can be any type, maybe a dipole, maybe circular, maybe a square, maybe elliptical, maybe a rectangle. There is a different shape of microstrip antenna. So actually, you are providing some, we can say that some discontinuity in the mediums, right? And that's why that is responsible for radiations. So microstrip antenna is just fundamental antenna is a rectangular microstrip antennas, and by changing the different shape of microstrip antennas, radiation can also change, right? Okay, then there is a smart IoT application environments. There is a key antenna considerations. Means you have a different shape and different requirement based antenna. Sometimes you need a flexible antenna, sometimes you need a teeny antenna, sometimes you need some PIFA kind of structures. Sometimes you have to integrate your antennas within the systems. Sometimes you need antennas with some kind of, we can say that the characteristics of the omnidirectional, the same amount. Like we can say that the unidirectional or directive based antenna. So that direction is that. Now, why microstrip antenna is important choice for it? The reason is I can integrate it as per my systems. So it can be easily fit on systems. There is a plan, non-planar antenna also. Non-planar means we can say which are just like a not a like a piece of there's a horn and let's say one basic example is a horn.
Breaking and
So I don't know. This thing is now it is okay, or I think hello.
sir, video off.
No problem.
And the sound is
Okay, so maybe your internet connection.
Yes, sir. Yeah.
That may be
Sir,
also
now it
possible.
is
I'll do.
okay.
Let me. Is it okay, madam? Can you see the screen, please?
Yes, sir. Yes. Yes. Yes.
Oh
Screen
yeah,
is
thank
also
you.
visible, sir.
Certainly, I think we have to uh, change you. I mean, let us stop the video. Yeah, I have stopped, madam. There is no issue. Yeah,
Yes. Yeah. Yes, sir.
that may
Please
be also
proceed.
another solution. Yeah. So, okay, so antennas uh, to consider that the I mean analytical part, and if you have some design concepts mathematically and by understanding the concept, if you design some basics idea, rough ideas, and that can be checked on software. And software provide you some kind of results. And on the basis of that results, because it's produced the Gerber file, let me say that HFS, because it is with us, high frequency structure simulator. This is the software that is available. This is, I mean, manufactured by NSYS. It is with us. So this kind of software provides you a simulations results. And on the basis of that simulation results, I can understand that what is the value of gain here, what is the value of bandwidth here, what is the actual ratio, what do you mean by, I mean, what is the front to back ratios, what kind of parameter like efficiency may be there, what is the impedance, right? So there are a lot of parameters can be observed by the software. So if I generate the simulation results, so I have a rough idea that yes, this design provides me this kind of output. So what happens then you can revisit it. You can change some modification. You can just change in a design. You can change in a feeding locations. You can change in a the patch shape and size. You can change the material. You can change. We can say that the structures like a single layer or double layer or three layers or stack kind of structures. And on the basis of that, my results may improve, and I have to observe it. If it is improved, now finally, if I feel that this kind of simulated results provides me a best antennas, so I can go for the fabrications. If I do the fabrications, now I have to do the testing. And for testing those antennas, I need a facilities. At least I need a vector network analyzer, VNA. If I have a VNA, then I can do the testing of these antennas, parameters like scattering parameters, right? But if I want to really do the some far field gain measurements and all, right? Even near field gain measurements, then I need some kind of answer. It is a chamber. It is anechoic chambers. And this kind of structures is finally this, I mean, this room where we can say that the absorbers are there. So where the one high efficient antenna is there, horn antenna may be my reference antenna. And my antenna under test AUT can be fitted at the second uh, terminals, or second, we can say that the end. So between these two, and one is considered as a transmitting antenna, right, or reference antenna. Second can be my antenna under test, and that is connected with the VNA. VNA provides me a gain also, right? But nowadays, the PC-based softwares are also available. You can fit it, your gain, and everything can be predicted or rather measured in the graphical presentation box. That is also possible. That kind of things are also displayed, right? So antenna design is a complex issue, but not a difficult. One is to work hard and they can do it. Analytical solution can only be found for a simple antennas. For a complex antennas, the computational tools are required. And the computational tools are available. For examples, it is the NEC, which is the numerical electromagnetic code. Then there is HFSS, which is the high frequency structured simulators. Then there is another one is a CST Micro Studio. Fourth one is a I3D. Then there is a PCAD by Antenna Design Associate. Then there is a PECO. And I worked in three softwares. One is HFSS, one is a CST, and third one is a PCAD. Right? PCAD is a very simple one because you can design, or you can, you can simulate it, some dedicated design. You cannot simulate your own design by the PCAD, right? So that's why it is, not a popular for a research point of view. But out of this all, there is always limitations of vehicles. But CST, HFSS, and PECO are good. I3 is also good, but it is for the planar antennas only. So it is another limitations. Otherwise, the HFSS can be used for a planar, non-planar, even though big size of antennas, right? So that is important, and that's why there is a high frequency structured simulators or CST micro studios are most popular, and you will find at the good laboratories, the NITs, IITs, and the national importance institutes. Yeah. So let me now introduce you about the.
Hello.
Hello. Yes,
Hello.
please.
Sir. All these softwares are freely available or paid
Out
versions?
of this, no, not, not a single one is a free, sir. All are paid,
Yes.
yeah.
All these
All
are the
these
paid
paid,
versions.
yes. But what happens, sir? Normally, for the learning point of view, student are doing some jugaad, but I think these are not a
Sir,
free, yeah.
student versions are
Available.
also
Yeah,
not the
it's
free or
available. It's available. They can download it.
stud-
Yeah, links are available. You can visit the NC's HFSS software, even CST Micro Studio. If you visit this too, you will find a 3 month student version. They allow for this small duration, like a 3 month. Again, you can register and you can do it. But there is also limitations of some values also. You cannot go with some complex design or some good iteration based output or some quality. There, but you can say that yes, some level of work can be possible with the student version.
okay,
Yes,
okay, okay, sir. And
but it is
for the
possible.
paid
It is
version,
possible.
how much is the cost of this software?
Yes, sir. It is there. Actually, always there is a negotiation. But nowadays, sir, HFS and CST can be possible at least five users can be possible with the 3 lakhs or something. And this
Oh,
is perpetual, so there is no issue of the long time continue of this service. Yes, they will not give you some latest version because for this you have to pay the fees. But yes, you can do the AMC with them, and with this AMC they will also do the that kind of upgradation also. It depends on
okay,
your
sir.
negotiation and your sir your what you can say that your purchase order and the condition what you define, sir. But
Okay, sir.
negotiation is always happens, sir. Yes, everywhere I think this thing is happens, sir. For the purchase, it is highly do this. because it is all our, no, it is a USA-based company. So we have to, I mean, our local subscribers, local dealers, to whom we can do the negotiation. Yes, sir. And I can give
Okay,
you,
sir.
I can give a company's name also if you are interested. HFSS is being promoted or rather sales by the N2PL Private Limited also. That's a Bangalore-based company, right? And second is the CSC Micro Studio is, Gujarat Jyoti Electronics Company. They are giving. If you visit their websites, you will find contact information and inquiries form also. Okay.
Okay, sir. Okay. Okay. Okay.
Please.
ठीक.
And you can contact me at last because I will share my information, sir. In future, I will help in this direction also. Right? Thank you.
Right.
Thank you.
Okay.
Okay, so let's go with some fundamentals on why this the antennas is needed for IoTs and all, and what kind of specific values are needed. And obviously, there are different amount of frequencies are also there. And when you have a different frequency, your antennas size and dimensions and types may also change. Because in antennas, what happen? The dimension of your antenna is based on a wavelength of operating frequency, right? Because if you have a lambda by 2 dimension, I think we all have studied that. Let me say that lambda by 2 dipole. So dipole length is a lambda by 2. So if your frequency is 700 megahertz or 150 megahertz, it makes a difference in the size also. If you are increasing frequency, wavelength is reducing because it is inversely proportional. And that's why the dimension of your antenna is also going to down. So if you compare your 700 megahertz microstrip antenna and 2.4 gigahertz microstrip antenna, you will find that the size reduction is very huge in this, right? So this one, and that's why I think that this flexibility issues are also nowadays coming into pictures. Let me say that if you want to fit some antennas on a body, right? Because in a flexible antenna, this thing is the one important application. One can find out the cancer detection also. My student and my team have worked in these areas. So point is that then you need your antennas like the flexible antennas can be easily, fitted on a body also. Even flexible antennas, the different materials are used which are flexible. Even jeans materials are also used for this. What we are wearing, right? So jeans materials is also used as a dielectric for this antennas. So same way, there are a lot of kind of antennas are there. Here is the for the wireless connectivity. We have to understand that how the antenna can play the important role. And another important thing is that the cable data communication is not effective or practical. We are knowing this. Even though loss is more in a wireless, we go with the wireless. It gives your flexibility, it gives your mobility, it gives you, person can be a mobile also. It gives you a IoT kind of concept, right? So that is very important. And that's why we have to go with the wireless connections. So popular wireless protocols, as you know, these are the Bluetooth, Zigbee, Wi-Fi, and these are operated at 2.4 gigahertz or 5 gigahertz. And standards such as some standards are also there, and these are the more popular because if you are interested in a good number of, the range, means the distance between transmitter and receivers are increasing, then you cannot go with the Zigbee or Bluetooth. Then you have to think of LoRa also, right? So LoRa and Sigfox are the support connection over a longer distance at lower data rates. Yes, obviously, there must be a compromise or trade-off between the parameters that operating in a sub-gigahertz band. Now, so designing an RF system and you have to take care of the protocols that demands the specialist skills. And that's why the wireless module or a reference design that comes with the protocols that's already integrated and critical hardware layout issues also. So you have to work on protocols, you have to work on wireless systems, you have to work on the hardware layout issues, and you have to solve it. While this can be greatly simplified design challenges, achieving a working solution is not an easy plug and play enterprise. So what to do? So in a world of uncertainties, technology is the one constant that continues to move us forward. Because let me say that before 2 years or 1 year, we were satisfied with the 4G, but now we think of 5G, right? Because data is a huge demand of the data. And during the pandemic, I think the learning objective was also changed. Was like offline to online. Everything was converted. So that's why the frequency requirement was also increasing, right? So yes, we have to establish a system which is a safer, sustainable, more productive, and connected futures. So the most evident then with the emergence of the IoTs, the system of uniquely identified interconnected devices that are enabled to transmit and share data over a wireless network. The point is, when you dream of IoTs, I think there is a lot of applications are involved with this. Because of the IoT, one can work from any place, right? So with this, I think we have to do the, yeah, I mean, find out the gap or rather bridging the gap between the physical and virtual world. The IoT is helping to create a smart environments by linking these devices to everyday setting tasks that helps individuals, businesses, and potentially all societies live in a smarter and more comfortable ways. And that's why it's growing fast. So, okay, now, as you know, the concept of the machine to machine learning or M2M communications utilizing low power networks such as ultra wideband, WLAN, GB, or Bluetooth to transmit data that have helped to drive IoT adoptions. Because machine to machine, you may have, I mean, you consider that the distance is a small one. I can go with the UWB, WLAN, GB, and Bluetooth to transmit this data. Even more so, it is the advent of low power wide area networks like NB-IoT, LTE, CAT-M, and 5G high efficiency transmission that has fueled IoT growth. So while 3G and 4G network facilitated wireless communication among people, but 5G allows for the greater connection among things. 3G to 3G, 3G and 4G, you can dream that yes, we are having some good speed. We have a video conferencing, but at the certain limits. Means among people, communication was established in a very well manner. But if you want to do the connections among things, that is causing the paradigm shift that has a directed focus on developing sophisticated IoT solutions for a range of industrial and environment concerns. So 5G allows the greater connections among the things. And obviously, because of 5G, one can dream of IoTs, IoT solutions in a very well manner. That's why I think we go with the wide bandwidth things also. And this has set the stage for a wide range of applications where meaningful change and efficiency can be operated. So IoT smart environments now can be as diverse as a farm that better manages its irrigation systems. You are witness that you have developed some projects with the students already. That is the IoT based irrigation systems. And that equipment maintenance to a major city seeking to create a more effective utility, metering, street lighting, energy, and other resource management and predictive maintenance of its facilities and operations. That we should understand that the everything is possible because of IoT. One can connect from one place to another. You are here and your system is long far to you, you can control it from the distance, I mean here only. That is the possible because of IoT based solutions. So IoT growth is very fast and there is data which is I mean, it is IoT growth forecasting that cellular and non-cellular IoT connections will triple worldwide between 2018 to 2021, to reach to 25 billions. Global IoT revenues will increase at an average annual rate of just 23%, and it can be reached to 1.1 USA dollar trillion by 2033. Likewise, that is a huge market in this area. Global IoT spending will return to a double-digit growth rates in 2021, and it achieves a compound annual growth rate that is about 11.3% over a 2020 to 2024 forecast period. And obviously, it is the forecasting by the one survey. So IoT performance rests on other technologies, and that is the antenna, because you have to finally transmit and receive signal in a free space. So major systems can be considered as an antenna also. So as IoT growth has been fueled by technology, it also has been facilitated by the strength of other technological advancement. So antennas are critical to transmitting and receiving radio frequencies, and along with the filter and power amplifiers. And that must work adaptively with fiber optics and cloud-based technology. So you have to think of antennas, you have to think of IoTs in such a way that they are compatible, they will transmit good amount of bandwidth, it can be compatible with the any mediums, right? From the system to the end users. Yes, there must be a limitless wireless connectivity between devices and database. That is again when you say limitless wireless connectivity. The quality of service is based on it. So you need a very large amount of bandwidth. So we can dream these things, I think, in 5G very well. While at the same handle high power signals and operate within a stringent thermal conditions. These are the functionality all critical to the development of an IoT application and performance of a smart environment. So IoT performance rests on other technologies, means it is antennas. So here you have to consider that wireless connectivity is no any breaking during the data transmission, and that is is more compatible to and performance smart. So this one is the information. So there is yeah, is and overall system layouts. So there is an even greater pre here less designs, right? You can say that you have to think your design, I mean antenna system design in such a way that which can be a more comfortable IoT in sense of efficiency, in sense of we can the wireless connectivities and other issues, in sense of safety, because if you have a good amount also, right? So that you have to work on it. It can be easily, I mean, as applying, let me say that simple dipole antenna is there. Now you have to energize at the center. There must be a feeding locations. There must be a feed points. So you have to analyze your antenna in such a way that, right? I mean, you have to rather radiate your antennas in such a way that that will give us a maximum amount of signal to your antenna, and antenna radiates majority of it, right? So you design in such a way. There is always the efficiency issues. As I said before, or a horn antenna provides you 80% of efficiency, which is the highest among all antennas. The other antennas are having a less amount of efficiencies. right? And because of the losses, because of the loss of materials, because of the loss of the, I mean, feeding points or impedance matching, there are a lot of things to be considered. So now another point is comes that is the antennas are integral to the IoT applications. So as you know, we are need of 5G networks and 5G networks and IoT. You have to design antennas in such a way that they are comfortable to each other. Active antenna systems are to increase the capacity and coverage is now coming to pictures. In fact, your energy antenna provides you some kind of beam and say that yes, this kind of output is available. But in active antenna systems or a smart antenna system, you can increase the radiation pattern in particular direction. You can decrease your unwanted radiations in particular directions. So that can be possible. So active antennas are mostly preferred now, and because it increases the capacity and coverage of radio strips. So there are also features a tighter integration of radio frequency, RF electronics with a massive element antenna to enable the miniaturization and the boost efficiency. And nowadays, you are not using the simple single communications like I mean single carrier and base communication. You have multi-carrier of the frequencies. You have orthogonal frequency division multiplexing, or you have a multiple input, multiple output, MIMO kind of output. So there is a multi-carrier frequencies, transmission and receptions. So that will improve the bandwidth requirement, I mean the coverage and capacity coverage. Okay, then another thing is, yes, advanced antenna system provides you again. This system comprises an array of antennas and closely integrated with hardware and software component to handle the increase the system complexities. So signal processing concept is also used here because when I say smart antenna or advanced antenna system or active antennas, then obviously I am using the signal processing concept also, right? So with the hardware and support components, we can handle or we can increase. I mean that will provides you a better solutions of the signals that finally gives you a good range. It gives you a good number of users can be accommodated properly. So that's why the capacity, channel capacity is also enhanced, and that is the high demand of today's era. This includes a greater steerability for adapting antennas, radiation patterns to rapidly time varying traffic and multipath radio transmission conditions. Simply put, more antennas translate into a faster data transfer, the lifeblood of the IoTs. So choosing the right antennas and customizing solutions are the key. Because I cannot simply say that any antennas play a, I mean, can be feed to the any IoT systems. No, it depends on your requirement, it depends on your bandwidth, it depends on your parameters, target parameter, it depends on the compatibility, it depends on the how the materials uh, structure is needed, what is the space for it, everything is considered, and then you can choose the antennas. So choosing the right antennas and customizing solutions are keys. The complexity of antenna system design and the availability of more frequency bands afforded by 5G have made choosing an antenna for a smart device that much more challenging. System designs cannot rely on plug and play options, but instead it requires more sophisticated planning and holistic assessment of all connectivity requirements, right? So you cannot say that yes, this every antenna is fit for every IoT system. So yes, you have to take care of that part. So in a variety of IoT applications, it is not unlikely that an antenna solution will need to be customized and include 2 or 12 antenna products inside a device, often the size of mobile phones, right? As you know, in olden days, the mobile phones, it was, I mean, in this, the simple monopole antenna was fitted. We consider as a beep antennas. We consider as a antenna which is fitted on a our cars, right? Because we are using FM antennas in the car. So there is a simple antenna were used. But nowadays, what happened? Nowadays, the things are changed. Microstrip antenna was, I mean, was adopted by every antennas because finally it gives you a better uh, in, integrated solutions, and the size of this antenna is very small, and you can, I mean, design within the chip also. Chip based antenna can be possible. Obviously, these are the microstrip antenna. Even in your laptop, if you see that laptop, again, there is antenna which is used is a microstrip antenna. So there are a lot of places where microstrip antennas are penetrated now, and that is because of its integration capabilities. Means it can integrate it or it can change its shape as per the target applications. It also provides you space requirement, which is a very less, and that's why we can go with that part. And these antennas must manage the different redundancy in services while working clearly and independently from one another. A physical trick of isolating antennas within the system design. There are some issues that is difficult to understand at this point, but I will just give a brief idea on it, how we can do that point. Still, I think this topic at this point is continued, that choosing the right antennas and customizing solutions are a key. There is another critical issue to consider in designing an antenna system for a businesses, industrial, or real world IoT applications. They must be designed to operate on on a secure network. One minute, please. While there are a range of antennas that can be used for Wi-Fi, Bluetooth, and GPS applications, there is increasing reliance on a cellular antennas that offer critical features needed for IoT systems. You have to take care of some parameters, right? And for example, with the exponential growth of wireless traffic causing more and more interference, spectral efficiency is a key, because what is the efficiency? I mean, what is the spectrum is given to you and how you are utilizing that is important. As you know, the bandwidth spectral efficiency or rather spectral efficiency, that is very important because you're given a 2 megahertz and you are not using, means your channel, I mean, you are all bands or I mean, number of users, or we can say the subscribers. If it is not accommodated within this, right, then the spectral efficiency is down. Spectral efficiency is actually, we can say that the within the given spectrums, how I utilize that spectrum. May I use with the 90% efficiency of that, means efficiency of that spectrals, or 100% or 80%? That is also important. Spectral efficiency is the key because you have to, because when you purchase this band or a spectrum, it is a very costly business, right? So you have to utilize properly. As a result, antenna must also be able to handle this bandwidth issues. Cellular antenna effectively meet this requirement. That's why we can use a cellular kind of antennas, which is a part and parcel of this. These are some types of antennas like cellular, LTE, 5G. Yes, it is for the GNSS. You design one antennas for this also in our lab. Wi-Fi, Bluetooth, Zigbee, ISM, likewise. So what is the IoT antenna requirements? Now another point comes into the pictures. First one is the high efficiency for a clean transmission and optimized battery life. That is important. Second is a high quality transmission, signal interruption against interference or a noise. This is also very important. Third is a harsh environment durability, means robust design in a dry and moisture prone area. Compact design, that is a miniaturization. Multiple frequencies operation, need for more bandwidth and compatibility with the global cellular networks, shorter development cycles, and that reduce the cost and all. These are the very important requirements. One is a high efficiency, second is a high quality transmission, Third is the harsh environment durability. Fourth is the compact design. Fifth is the multiple frequencies operations. Sixth is the shorter development cycles. So we have to reduce the cost because the technology is upgrading is very fast. So within a small time, the system can be, we can say that outdated, right? So IoT antenna requirement is this, and as a developer, as an antenna developer, we have to take care of this part. Yes. So together, these various technical and market demand or make clear, okay, this is about the right antenna skills and all. Let me give you one example of the smart IoT environments where smart antenna system designs are essential. So we discuss that part. So here, if you see that the smart antenna system designs, it makes a sense to look at the two major trends in IoT application. One is a smart tracking and second is a smart building, right? These are the because when I think in Gujarat we are, I mean, if you know, there is one place known as a Tolera, sir. So this one is a high tech city because in the olden days it was the just business center of the India also. And that was possible through that sea on because sea was, I mean, near to it. Now there is a very long distance between sea and that Dolera city's boundaries. It is just in, I mean, in between my place Anand and my native place Bhavnagar. It is the Dolera. So this Dolera, sir, is basically what they are developing. They are developing this kind of smart buildings, rather smart cities, which consist of the smart tracking and smart buildings. Lot of things, even your drainage systems, even I mean sensors are available each and every point of things. So that is the, I mean, the concepts. Now it will come, and that will be adopted by the builders and some those good developers also. So smart tracking and smart buildings are very important, and where the IoTs and one, I mean, we can say that it is the IoT application or IoT solution for this cases. So in both the cases that examine the market issues, challenges, and requirements that clients face to develop the optimal solutions. So regardless of these applications, there are clear standards that must be met in focusing on data management and protection as well as backup battery performance requirement. These are very important points, right? Because you take care of the how the data can be managed and protect. The protection is also very important. Otherwise, your control device may be a controllable by the others, and you have to avoid that, as well as backup battery performance requirements, right? So this 2 to 3 things are very important and we have to follow. Other pertinent standards focus on installation practices, firmware, upgraded communication devices, diagnostics, and climate resistance measures as the environment in which an antenna operates will impact its functions. So as I said that if I consider the two important applications where the IoT, I mean, will be penetrated, I think it is penetrated already in a developed country, but it will be penetrated in our countries in the past. That is the smart tracking. So it is a growing trend presenting a significant market opportunity for companies looking to enter the space, right? Every vehicles are tracked, right? It's a smart tracking. So it is increasingly being developed for use in telematics and onboard diagnosis, OBD. Two major areas within the global vehicular and transport industries that are experiencing a significant growth by this smart tracking concepts. It is also used for the asset tracking of physical assets, again used in a transport as well as with a global distribution and logistic players. Another area of growth, the IoT supported asset tracking market is expected to account for 93% of the all enterprise and industrial IoT solution in the current environment. As you know, industrial IoT solutions are also now developing or rather going in very high speeds. So in building a smart tracking application, the customer has to consider a number of technological challenges. First is because I am an antenna developer, I am an antenna system engineer, so I have to concentrate on my recent areas or my specialization. So here, concentration is there is a requirement to ensure the right antenna systems. Because tracking is again, it is a wirelessly happen. So you have to do a better antenna requirement, which can withstand a good spectral efficiency. I mean, it has a good spectral efficiency, good bandwidth. We can say that the good tracking capabilities like the radiation amount is high, signal level is high, no interruption by the others, no disturbance by the others, right? And your antennas provides you a better connectivities because on the base of connectivity, everything will happen. So wireless connectivity is very important in IoTs, right? And that provides by the antenna system. And that's why I'm concentrating on it. What are the challenges and what kind of solution can be possible in this? So first one is, this is about smart tracking. Controlling the orientation of the antenna as well its radiation pattern performance. This is very difficult because what happened, you are just doing the tracking and you don't know about where your vehicles or where the objects where you put or you fit this device is there. It is also moving, right? So controlling the orientation of the antenna, because if you fit the antennas and in particular direction, if you radiate it, then what is happened to the other directions where this kind of tracking is needed. So what to do? It operate with the multiple frequency, right? Means not a single frequency is not a solution now. You cannot say that yes, my 2.4 gigahertz antenna. I mean, if you draw the return loss, so this return loss, because S11 parameter is very important. So if you observe this S11 or scattering parameters, because for a high frequency, power is also changing. At high frequency, voltage and current cannot be directly measured. You have to measure the power, but you have to measure with the scattering power. And that's why the vector network analyzer is fitted. I mean, it is needed. So VNA provides you a result of S11. It can be also possible by some software, because if you design your antenna, then the scattering parameter is observed by software also. So when you see S11 parameters, scattering parameters, right? So if it is operating, means there is the signal which is possible is a negative D pocket. So if it is possible at 2.45, so it is a single frequency antenna. But let's say that you have designed your antenna in such a way that one is providing you a negative dip at 2.45 gigahertz, second negative peak maybe at 5 gigahertz. Then what happens? Then you can say that it is a dual band antenna. Let me say further, there is another negative dip is also comes maybe at 10 gigahertz, right? So what happened now? There is a more than two frequency of operations comes in picture. So it is we can say that the multi-frequency antenna. So single frequency antenna does not provide this kind of uh, we can say that the orientation of the antennas or I mean that radiation in a particular distance or particular directions. So better you go with the multiple frequencies, because if you have 3 to 4 different frequencies, I think it can be easily radiated, it can be easily observed, and there is a minimum chance of we can say that the co-channel interference or interference at last. So it operates with the multiple frequencies and provide the omnidirectional performance. Obviously, there is another harsh environmental conditions. This is another challenge. Then there is a robust design in a dry and moisture-prone areas. So you can design your antenna in such a way that will solve these issues. Because when you fit the system, normally system once it is fit, even though our DTH TV, if it is fit on our terrace, normally we are not taking care of it. Once it is fitted, I think till the maintenance is required, we will not even clean it also. So that is the happen. So that's why you have to design in such a way that that can be easily, I mean, without maintenance also it run itself. There is uninterrupted cellular signal for a diagnostic performance. There is the uninterrupted cellular signal for diagnostic performance. So solution is you need a high efficiency. So deliver high efficiency, that is the solution of it. Fourth one is the battery power saving. If the battery power saving is another challenge, then how it can be combated? It can be combated like this, that ensure high efficiency to prolong battery life, right? Then there is a global tracking is the major issue. Then it provides service across the globe, ensuring the multiple frequency band. Multi-frequency band is the solutions, and that's why if you compare with the 4G and 5G, even 3G, I think the frequencies are increasing. Multi-frequencies are there. Multi-carrier is also there. So that is the solutions for global tracking and all, right? So obviously there are two issues that dramatically impact the performance. An IoT startup business focused on a global tracking was using a variety of antennas that made their devices bigger, heavier, and more expensive to produce. They were also using a cheap antenna that did not allow for the granular tracking data needed, nor did they understand complex radio frequency requirements. So either of this, one is we can say that uh, the variety of antennas are being used and that made the devices like the bigger, heavier, and more expensive to produce. They can also use the cheap antenna, right? The antenna which is fitted in the chip also, or it did look like a chip. The chip antenna that did not allow for granular tracking data needed, nor did they understand the complex radio frequency requirement. So these are the two issues were dramatically impacting the performance. What one is because of the variety of antenna, it becomes bigger and heavier. Second is because you are using a cheap antennas, with the small antennas within the chips, then the issues are like this that it does not allow granular tracking data need that and it not did they understand the complex radio frequency requirement. These are the two important issues were dramatically impacting the performance. So then solution may be a newly formulated antenna designs can be used like this, that custom design embedded antennas for 5G connectivity that enable the customers to build a reusable smart system more as a mobile phone, an IoT device for real time parcel parking and all. This is possible. Reducing the weight of the antennas to both lower the cost and size of it, as well as the improve the quality. So implementing on a board surface, mount device antennas to make the entire device part of the antenna solutions. If you use antennas in a board, that will be a complete solution. This also created the most efficient and manufacturing process. This costing becomes also. So reviewing the design to improve the battery life and reconfigurable the board layout to properly place radio frequency components and maximize the ground plane, which enables the radios to work and avoid interference. Antennas and RF components tend to be the most underestimated parts. Normally, what happens we are designing, but that is the mostly and underestimated parts of the design. And because finally, what you are giving, whether they are compatible like electromagnetic interference or electromagnetic compatibility issues are being taken care. If it is taken care, then you have to, there must be a good separation between your feeding signals and your, we can say that the antenna itself, right? So engineer with the antenna and RF expertise can help bring the specification of an IoT product to life. So now the second trends is also, is increasing as far as development the product is concerned. It is a smart building. Nowadays, smart buildings are always, happens. The smart buildings have become one of the fastest growing technologies, and it is also known as a prop tech industry, the application of information technology and platform economics to real estate. So while the primary market drivers behind the development of smart building is the growing concern over energy utilization. So this one is the smart building is always used. There are other focus areas as well as security, building management, eco-friendly living measures. This is very important. So in constructing a smart building, there are a variety of technological challenges to address in designing the right antenna system and choosing the optimal antenna options. This one is a very important. At the time of construction, there are a variety of technical challenges to address in designing the right antenna system and choosing the optimal antenna options because right antenna with the better performance that can be selected. Obviously, here also there are the challenges and you have to find out the solution. First one is physical construction material. So metal concrete can impede the antenna signals. So physical construction material that will affect on antenna. And I've already write two books on this construction management side, uh, so, the automations, where the solutions are given for the different issues. With myself and Professor Jayesh Vitroda, who is a associate professor of civil engineering, we both have written two books also. And this one is volume one and volume two, that is the construction technologies or construction management with the help of automations. That we have written and we have seen the some issues relevant to the physical construction materials and how they create issue for RFID tags and all, right? So uh, yes, we have formed the one group of civitronics kind of thing, civil and electronics, because it's a high time to work together. It's a high time to work as an interdisciplinary connections and all, right? So we have to work in this way. The solution is deliver highly efficient antennas where signal performance is not significantly affected by a building's construction materials. So that's of course you have to select antenna in such a way that which is the highest efficient or highly efficient, and that will there is no any effect on the signal performance because of the this physical construction materials. Then second is the interference congestions. Means competition between a wireless services creates interference and signal noise can block services, causing access points to compete for the services. So you have to ensure clean, free of interference transmission. So site selection is very important because when you fit it, I think you have to take care of that sites. And that's why the survey and everything is. Because in a cellular system also, right? Cellular companies, when once they, they have to survey the sites and then they find out the cell site locations. Everything, here also at the certain small scale, but in a building also, you have to find out the, or you have to ensure the clean or free of interference transmission. Very little high frequency background, RF. A smart building, it is happening because it is always, it is made of, as you know, the concrete and all, right? Majority of it. So very little high frequency background, and that's why you have to implement the right antenna for it, right? You have to, again, high efficient, high gain antenna can be a better solution because if you have a high gain, I think straight signals can also work, right? Next one is a inability of 5G to to penetrate windows and walls from the outside. Because when you are increasing the frequency, the wavelength of this frequency is very small, right? Let me say that simple example. Let me share with you. Initially, I think probably in the era of 1980s or 90s or even 2000, we were use a simple. We can say that the Yagi antenna, the antennas with the different what we call is the arrays, different directors. right? So that kind of Yagi antennas was working at a UHF frequency, maybe 900 megahertz, 700 megahertz. Nowadays, at your home, we have a DTH, and this is obviously maybe working at KU band or means high frequencies now. And that's why what happened, these signals becomes more straight signals also, right? Because the bandwidth is also small one. And when you are increasing frequency, your direct to direct propagation is stronger, but you cannot go with the other ways also. Like the multiple propagation becomes an issue also. The point is, nowadays, even small, I mean, if the rain is coming, right? If the rain is there, then also it creates a problem. You cannot connect because it is through a satellite only. So this always, I mean, you are finding the breaking of the signals. We are not getting anything. So at a high frequency, the even raindrops can also create good attenuation or high attenuations. So point is, if you are increasing the frequency, these issues are there, and now you have to solve that issues. So as I mentioned, inability of 5G to penetrate windows and walls from the outside. And that includes the micro cells and the small cells to enable the 5G performance inside the building. You can fit a small cells there, right? And that, I mean, connection is through that cells only. That's where we can avoid the multiple reflections on shining effects, and we can establish the connections with the 5G also. Resilience and security requiring license frequency band certifications. Yes, so solution may be provide the engineering supports and expertise to deliver a successful IoT design and certification supports. Yes, you have to take care of this. So yes, so another situation need to be discussed, like a real estate developer constructed smart building in a major metropolitan area to enhance the building management and provide the tenant amenities. The building was designed to feature significant security and surveillance protocol, real-time energy reporting to lower costs and increase the efficiency, and that predictive maintenance models to avoid the problem and save costs. So these are the some floor plans and cyber securities. These are the situation. And obviously we are using the MIMO antennas, as I said, multiple input, multiple output, and multi-frequency is the solution for this kind of even industrial IoTs or IoTs. And we have to develop the antennas. And obviously there is embedded antennas which support the smart indoor cameras and cloud-based automated access control systems. You can also use the 3D antennas assemblies to facilitate the real-time monitoring of electric, water, and gas meters to lower the energy cost. This is happen, and as you know, it will come also. Like electric meter was in our house from longer time. Gas is coming now. Gas is there, right? Water will be coming. Water meters and all. You can sort them, right? So increase the energy efficiency and secure energy supplies, all while reducing the carbon emissions. Cloud visualization to monitor and maintain a building from miles away, including real-time alerts visuals. So this thing is the um, when you have antenna system designed for various IoT applications in a building that includes this kind of problem and solutions, right? So now, yes, you have to select antennas for a small IoT device, and that with these challenges and with the solutions, you can do it. Yeah, the antenna is often required to fit inside the device enclosure. That is also nowadays, I think, if you know there is a radome kind of structure is used, right? You might have seen some BSNLs or some towers, right? There is a radome kind of structures, like a drum kind of shape and everything. So that kind of enclosures are also demanded because that will protect your antennas from the some uh, problem for we can say that the winds, even for the problem of the dust and all, that can be also avoided. That will radiate efficiently. So antennas performance can be enhanced or rather uh, continues for a longer durations. Uh, on the other hand, a suitable antenna should also have a high efficiency and adequate bandwidth coverage. These are always the issues, and we have to work on it, like efficiency and adequate bandwidth. This is always a, I mean, very important role for establishing the systems in a small. And for those reasons, it is best to consider the antenna design issue as early as possible in the project on the basic type. From an overall RF performance standpoint, the entire system is guided, right? Obviously, it is an integrated part of the antenna. So PCB antenna can be attached. Ground plane must be the top layer of the main circuit board. PCB antennas are intended to mounted at the edge of the circuit board. Normally, it is available at the edge of circuit board. Because space constraint inside the enclosure demands more flexibility in positioning the antennas. The PCB antenna can be connected to the main board using a miniature coaxial cable. This kind of means you can use the one miniature cables, and with this your antenna can be done. So obviously, as I said, integrated antennas are the better solutions, which is for the small IoT devices, right? And stamped metal antenna is a suitable alternative, which is the integrated antennas which can be fitted with the system itself. And yes, we can change the other component, like you can do the passive and active antennas. In active antennas, you can use different semiconductor devices, and can change the performance of your antenna. Some customized antenna solutions are also there, which is the custom solution. The standard antenna capable of meeting the system performance requirement usually offers the most effective solution, benefiting from easy and fast of the self-availability. So here is the size constraints are extremely tight, because when you design the system, it is something like you are designing your systems and at last you are thinking of antennas, right? So size is always constrained, and you have to take care of electromagnetic interference and the EMC compatible environment, right? So uh, design and the suppliers need to know the frequency bands, bandwidth, efficiency, link budget, and any multi-band requirement. So that is the important thing. Okay, then as I said, EMC compliance need to be take care. Even electromagnetic interference, what is the amount of EMI is generated, that is also take care. And that's why EMI, EMC certifications are also there. Some laboratories, they offer you, if you want to design any systems, right, then they offer you, I mean, they ask, it's electronic system, then they need some certification of EMI, EMC compatibility. So this compliance, I think we are planning to distribute within short time. We already put a proposal to our higher authorities about this kind of facilities and this kind of instruments for the EMC compliance. With the help of spectrum analyzer and some supporting device, one can do the EMC compliances also. Yes, so selecting antennas for a small IoT device. Okay, there is an Internet of Things in a vehicle communication. I think that part is right. Yeah, and we have to understand the ecosystem of Internet. I mean IoTs. So we go with this. Yeah, yeah. Let us understand the IoT system, or rather ecosystem. You need a sensors and gateways. They are uh, connected in a bidirectional way. You have a network structures where the networks here is big data, and you have to do the cloud infrastructures where analytics can be possible, right? So the IoT ecosystem, it comprises of this kind of all the components together. So as depicted below, means above in figure, it consists of sensors, gateways, infrastructures, right? And basically part of the IoT ecosystem, and big data and analytics. And that's why, as you know, on the basis of big data and analytics, a lot of programs are going on, a lot of certification courses, the job opportunities also are also increasing. That is because of the effect of IoTs and its. Yes, then the question comes that what kind of frequency that I have to take care at the time of design. So obviously I have applications, and technology and frequencies. So for the smart homes and smart buildings like the Wi-Fi, GPS, Zigbee, Z-Wave, Bluetooth, HART, ISA 11.11a, likewise, this can be this can be a technology, and this technology is are normally working at the frequencies of 2.4 gigahertz, and second is the 1575.52, 1176.55, 915s, 2.4. Likewise, there is the 2.4 gigahertz for the April and likewise. If you are using a smart agriculture, smart cities, a smart agriculture, then you can go with the LoRa because it gives you a better, long distance. So students are developing some projects on it. Frequency operations are like this. Obviously, it is a lower UHF and higher UHF. Smart cities for this also you can, both smart agriculture and cities, you can use a LoRa. For a medical, there is a Sigfox, MDA, and IEEE 802.15.6. So with the different frequencies like 868 megahertz, 900 megahertz, 2.36 gigahertz, 2.4 gigahertz. It can be also used in avionics, right? So in avionics, there is a 4.2 gigahertz and 4.4 gigahertz, but it is normally used. So these are the frequency bands and IoT applications. So as the antenna system developers, designers, you have to work at this frequency and you have to work of the target parameter needed for making this system adaptable to your antennas. And that kind of things to be taken care by system design. Yes, RF is now used in a more applications, driving the development of protocols to meet the needs of specific applications. Here, the distance versus data rates are given by using the different method like Wi-Fi. Then it can be go out to certain meters. Data rate is high, because is also the second of it Jigway, that is the this. And LoRa provides you a data rate is a small one, but the distance is very good. And the cellular is finally provides a distance in a kilometer, even 6 ports and you are also. This one is uh, the applications compared to data rate and distance. So one can select as per their target distance and target data rates, the standards for their applications. Yes, antennas can become in a various shape and size. So this kind of things are there. This kind of antennas can be also possible. This one is demanding for space constraints and all. But this is embedded antennas. As you can see that the size of this antenna based on their materials, based on their requirements, it is. Yes, this kind of we can use connectors and design options include the PCB mounted and remotely located ones. Often the application will dictate the most appropriate. This kind of antenna can be also preferred for IoT system. That falls. Then there is a PIFA kind of antenna. So this is the antenna, right? This is also the antenna. It is a PIFA kind of structures, and obviously it is with the part of its board. So it is a part of this which can be considered as integrated antenna. So you can see that obviously the frequency of operations and performance of these two different antennas are different. This one is a facility which is available at my lab, which is a chamber where I can fit the antennas. Here is the antenna under test, and this one is considered the horn antennas, which is my reference antenna. So I'm giving the signals to my antenna under test. Absorbers are there; it receives the signals, and that will okay. There is a reflection theories based concept is happened to DNA. So what I am giving, that signal is received or is, accepted by my antenna under test. If some of the signals are not there, right, or you can say that some of the signal may be go backward, that is absorbed by the absorbing materials. So these are the absorbing materials. You can see this one is the length of it, right? Okay, and this is the brochure what I normally share for my presentation. That yes, we are giving the facilities for the students, for the researchers, for testing their uh, passive devices at our place. So I'm in charge of it. So I'm sharing. This is my responsibility also. These are the some of the antennas which is developed by my researchers, right, and tested. Like this one is for the navigation application. This is for the LTE applications, long-term navigations, right? And they both the fellow have done the PhD from GTU. So I have mentioned a few antennas. Till now, I designed some planar and non-planar antennas. Probably it is in a good number, but I have put some limited antennas, which is developed by myself. Again, this one is a requirement of systems. Uh, how you, I mean, establish this one. So you need a vector network analyzer, which is the heart of this complete setup. You need a PCB prototype machine, maybe automatic or maybe a manual, whatever with you. If you have automatic, I think you can simply give a Gerber file, which is generated by the your software, maybe HFSS or CST, that can be directly given to it. And that on the basis of Gerber file, it will use your output here, right? I mean the PCB output, and that can be tested finally on the chambers. So this one is the three minimum requirement, right? And plus one software that will finally work. I mean, it is okay for testing and development. My conclusion of this presentation is this: the variety of standard antennas that I need to design for a frequency appropriate to IoT applications, and it should be compatible with the extreme size and power constraint that apply to typical IoT endpoints. Successfully integrating an antenna is not a simple plug-and-play exercise. It requires careful selection, awareness of the effect of other components in the system, including the enclosure. The fine-tuning of the antenna's speed and positioning can be done, and it's worth keeping an eye on technical developments too. The best to assert the trade-off between the utilization efficiency and bandwidth. You can go with the different structures like graphene and textile antennas. These are the some references. So I've already submitted this PPT to Madam, right, Madam? Did you receive my PPT? Yes, you can share to your, I mean, our participant, so they
Yes, sir.
can go through it and they can contact me for the further also. These are the
Yes.
references, yes, and this is the my affiliation with the professional memberships, and this is the qualification. This is the detail about my institutes, brief detail. I am looking at some portfolios also. This is the lab. I like this. That's why I'm putting this picture. Thank you very much. This is from my side. Questions can be asked by the participant. Yeah, please.
Thank you,
I will
sir.
try to justify. Yeah, thank you.
Yes. Friends, if you have any query or question, you can please discuss with sir. Any question?
Good afternoon, sir. This is Dinesh from Manipur. Just want to put up a question regarding the antenna material that you just talked about. That's using graphene.
Yeah.
So, okay, sir. Is it related to dielectric resonator antenna, sir?
Yeah. My point is when I say that graphene, actually I'm not working on graphene, but my one of the friend who has worked, and this one is normally used for the absorbers. They use antenna. I mean the absorbers for the absorber design. They did this, but yes, I think graphene has a dielectric constant, and if it has a dielectric constant, it can be used for the antennas design also. Yes.
Okay, sir. One more question, sir. If one wish to pursue PhD in antenna technology or something like that, so specifically, I just want to pursue. I'm just looking for an area where I can pursue my PhD in a dielectric resonator antenna. So what
Yes.
are the challenges that I can expect? I may expect for taking up such an area.
Yeah. I think that's a good question. And still, I mean, you are talking about the others or you are talking about your own case?
Since my own case, there are some. Say to be very frank here,
Okay.
as
Okay.
I'm from
Okay.
Manipur, and there are many limitations. Like I don't have any institution which
Nowadays,
where I.
I understand. I think you are Dinesh, right?
Yes, sir. Yes, sir. Yes, sir.
Professor Dinesh, I think it's a challenges are always there, but the solution is also possible if you are working sincerely and if your attitude is clear about this. My point is, if you are interested to do some research on dielectric resonators, yes, you can go with the topics of it, because there are a lot of chance, because you can develop some 5G subband frequency based dielectric resonators, because when you go with the higher frequencies, maybe a 30 or 40 gigahertz, then again you have a problem of the fabrication and testing. In India, there is a very limitations places where this thing is happening. And it is difficult to enter in some central organization like ISROs or DRDOs, right? So point is, you can design up to a 10 gigahertz or probably I mean less than 15 gigahertz that can be easily fabricated, that can be easily tested. And nowadays, what happened? A lot of private industries are also offering this kind of testings. So I mean, by the if you can send if you design it, they fabricate it also. You have to only design it by the software, and you have to send a Gerber file. They will do on behalf of you the fabrications. And if you are interested, you can go there and you personally see that how the fabrication can be done. But otherwise, they will measure also, and they will generate these parameters or rather, I mean that results, and then they can send it to you also. It is not actually a very ethical way, but my point is the facilities are limited, so you can approach, or a lot of researchers are approaching this way also. Yeah.
Okay, thank you, sir. That's a good idea, sir.
Thank you.
Good
Thank you.
information.
Thank you very much.
Anyone? और किसी को कुछ पूछना है? You can ask in Hindi also.
Let me remove the sharing. Yeah. Still sharing is going on. Na?
Yes, sir.
1 minute. Yeah. Stop sharing. Yeah. And let me start my video. Yeah. So we feel that yeah, I'm physically present. Yeah. Thank you.
Sir, I think there are no questions. They asked in intermittently during the presentations itself.
So then better you please share my PPTs to them. So
Yes, sir, I
my
already
contact
shared in.
informations
Yes.
are there.
Yes. Yes, sir.
I'm happy if
Yes, sir, we have
any
already got that.
faculties will approach me. Huh? Please. Hello? Anybody
Yes.
saying something?
Yes, sir, I already shared with them. So participant is saying
Yes,
they
good.
got your PPT. Yeah.
Oh, thank you. I think it is my moral responsibility also. I normally share my, I mean, I share my screen everywhere. Yeah, because
Yes.
what I'm prepared for that talk, that should be shared to the participant so they
Exactly.
can have some information. Yeah.
Yes.
And you have a test. You have a test also, right? They have to go with some
Yes, sir. They are
MCQ
having
kind of
MCQ
test. Yeah.
pattern test. Yes,
So
sir.
that's why we have to supply also, madam. Yeah.
So, sir, on behalf of all the participants and from HRDC Nagpur, I extend my thanks to you, sir, for accepting our invitation and delivering such a wonderful session.
Thank you
so
very
much.
much. I wish you all
sir.
the best to all because I think we are learning by this kind of programs and all. Thank you very much.
Thank you so much, sir. Thank you.
Thank
Have
you.
a nice day, sir.
Thank you. Okay.
Thank you, ma'am.
Thank you.
Thank you. Thank you, all of you. Now we will take a
Thank you,
break of
sir.
half
Thank
an
you,
hour.
ma'am.
Yeah. I'm ending the meeting. I am ending the meeting. You please join by 1 o'clock sharp.
Okay, ma'am.
And again, one thing I just want to tell you about meeting logging. ठीक है, अगर आप लेट ज्वाइन करते हैं तो मैं मीटिंग लॉक कर दूंगी लाइक इन द मॉर्निंग सेशन एंड आई विल नॉट एडमिट एनीवन इन द सेशन आफ्टरनून सेशन. सो प्लीज बी ऑन टाइम. ओके, आई एम एंडिंग द मीटिंग नाउ. सी यू एट 1 PM.
नेटवर्क इशू मैं 2 डिवाइसेस से कनेक्ट.
जी, जो लोग पहले ज्वाइन करते हैं और बाय नेटवर्क इशू इफ दे आर डिस्कनेक्टिंग आई एम एडमिटिंग देम, क्योंकि मैं पहले ही आप लोगों की अटेंडेंस मार्क कर लेती हूँ जो लोग टाइम तक ज्वाइन करते हैं. जैसे भी हल्दर सर बीच में डिस्कनेक्ट हो गए थे लेकिन उन्होंने 10:30 पौने 11 बजे ही ज्वाइन कर लिया था, तो मैंने उनको एडमिट किया बिकॉज मैं उस टाइम के पहले ही आप लोगों की अटेंडेंस ले लेती हूँ. उसके बाद अगर कोई आता है तो आई विल नॉट अलाउ देम प्लीज. एंड प्लीज थोड़ा सा शेड्यूल फॉलो करिए, पंचुअलिटी फॉलो करिए. सभी लोगों के लिए है. मेजॉरिटी ऑफ द देम आर वेरी पंचुअल बट फ्यू पार्टिसिपेंट्स आर देयर जो टाइम पे ज्वाइन नहीं हो रहे हैं. सो मुझे प्लीज़ ऐसा कुछ मीटिंग लॉक वगैरह करने की नौबत मत लाइए, क्योंकि मुझे भी देखना पड़ता है कि लॉबी में कौन खड़ा है, एक एक करके उनको एंटर करना पड़ता है. तो इट इज़ माई अनदर टीडियस टास्क फॉर मी. सो प्लीज़ बी ऑन टाइम. सो टेक योर लंच. सी यू एट 1 PM. ओके.
Okay, madam.
या.
Okay.
ओके.
Thank you, ma'am.
थैंक यू.